Okay, this one is for Paul in New York. This is the 955 HPC Plus. So he did use the rewards. I do still have the rewards, the loyalty program, whatever it is on my website. So he cashed in and got 10% off the radio, which is a pretty good savings off something, that cost what these cost. So congratulations on that. I'm glad that you used it because that's what it's there for. You did ask about the call sign. Yep, I can put that in. It'll have the call sign on the display. The extra frequencies, this does have a VFO option as well as a WX. I just sent you a message about that, but I believe there's a VFO option in the WX as well. The radio will receive anything from 136, I believe, to 174 megahertz, only in reception, though you can't transmit. So, as well as the standard no weather frequencies. I think you can also program in your own if you want to overwrite some of that stuff, and it would be stored in there. But I think there's also a WX VFO, and don't hold me to that, but let's try to find that out really quick. Okay, so the radio comes on still in 10 meter, but we can obviously see that you can use the band option for some of this stuff. And there's the other band. So if you use VFO, that's how I recommend to use the radio. Now I know everybody has a preference, so you can customize how you want this to react and this to react. So the fine is going to usually stay like that. So we can go through it like this. Fine will be receive only. We want coarse. I'm going to make coarse 5K. I think that's a little more acceptable for what we're doing here. And then channel selector, I'm going to make that 1K, just because I think it's easier for me. Now you can obviously change this. When I send the file, it's going to be different, but it's just a demonstration of the VFO. So if you're in VFO now, you can go continuous 5K resolution the whole way through. Or you can go 1K if you want to go 1K like this. So if you're on sideband or something, you want to go 1K, you're going to be able to tune like this with the channel selector. If you want to go 5K, you can just do that. So that's how I would recommend it. But it's entirely up to the user. You can make this 100 hertz, I think, if you want to, or something. So it really doesn't matter. If the option's there, you can use it. If we go to WX, so now we have, I believe, the VFO option here as well. So let's see. Yeah, let's see what it's going to do here. Maybe we have to customize this one independently. I haven't played around with this too much, but let's find out. Let's try 10K. Yeah, so now we can go like 10K. Don't think this one does anything though but there is a VFO here. So if you wanted to move around, let's say in the megahertz range, which you probably would here to get around faster, now you're in the megahertz range. So let's say you want to go down to 2 meter, 146, 520. So it takes a little bit of work to go back and forth, but it's very doable. My new QSL card just fell. But this is something I don't know if I've shown it completely before. It'd be nice if the course wasn't still enabled. So we'll go 10K. And then we'll go 520. 146, 520 right there. So now we're on the national simplex. If somebody was talking, as long as you have an antenna that's within range, even if it's not typically a 2 meter antenna, you'll probably still hear somebody. Although you wouldn't hear them as good probably as what you would on a 2 meter antenna. It's just the way frequencies work. An antenna that is resonating in that band will work better than something like a 10 meter antenna or a CB antenna or whatever the case may be. So that's how that works. And that's in the VFO option. Now I'm assuming if we switch out of that here, yeah, now we're in, whoops, now we're in the standard. So now we just have the standard NOAA weather. And there's my local NOAA weather right there, picking it up off my dummy load. So it's working good. So this is in the standard. And you can program, I think, more in here. So if you want presets, you can program them in with the computer. But if you want VFO, then obviously, you know, we can do like I just said. And I'm assuming most guys are going to want to listen on the 2 meter band or somewhere on the MERS band or something like that. If you're in Europe, I think in Germany they have what's called the Freenet. You could listen to the Freenet on this radio, I believe, which I think is a very low power band in Germany. The guys in Germany that watch my channel would know more about that than I do, but I think it's cool that they have something like that there. I think it's just slightly above the, I want to say, and I'm just guessing here, that's in the 149 megahertz range or something. It's just above 2 meter. And their band plan in 2 meter may not even go to 148. I'm not sure, but I don't live in Germany, so I wouldn't know these things. I only know what we have in the USA. But that's how that works. So I've covered that. So now we're going to get out of this and just go to any mode that we're out of. If you want to go to, let's say, 12 meter, then you're going to have to do something like this. To get there faster, you can go 1 megahertz like that. You tap the color, it always goes out of that. You can go down to there. We can see the full extent of the radio from 24 to 30. Okay, so we'll go back and we will tell it now I want to go 100K so I can get there quicker. And we'll get up in there, and then, you know, obviously we need to adjust that a little bit more. So I still think that this would be okay, although you may want to change it in amateur radio mode to a little less aggressive on both of these. So you may want this to be 100 hertz, and you may want this to be like, you know, 1K. That way when you're tuning, you know, we can tune through the band now in 1K steps. But we all know on amateur radio, nobody's operating on any given frequency. It's just wherever they end up. So now you could go in the 100 hertz steps here. So we can't see the number outside of this, unfortunately. So, you know, that's the only thing. The counter only goes this far. So it'd be nice if there was maybe another digit, but there's not. So we can't do anything more than that. So 100 hertz. I'm going to 100 hertz steps. Otherwise, you can shut the course off. I don't know why you'd want to, but you can. So for amateur radio, that might be a little more useful. And then, you know, however you want to use the radio, there's no right or wrong way. It's just you tell it what you want it to do, and then it's going to do it. So hopefully that makes sense. It's 8 minutes of, most guys probably could care less, but you did ask about a few things, so I just wanted to show you that. And the same thing would apply on 10 meter band. You just have to use that megahertz to go up. So you'll use this one a lot, and you'll use this one to change when you're in the menu. This is your toggle in the menu to cycle. So you'll get used to it. It's way different than the other radio you have, the Pro, Anytone Pro, but performance wise, this one's going to do the same power. But it's going to be more aggressive on AM. So if you like AM, you're going to like this one better for sure. Okay, so I'm putting your call sign in the radio right now. So it should, when it says it's done and I power off and power back on, it should be there. So let's see. Yep, there you go, is your call sign on the screen, so that's cool. As far as that goes, I think is the VFO option. Yeah, so everything is default now. So I'm not going to mess with that. I'm just going to leave that alone. I've kind of gave you a tutorial on how to use that. So now we're in the 10K step size now. This is the default anyways. And I'm just going to test it in this band. This is where you align the radio anyways in this band. That's why I leave it here. It's on my dummy load, and this is where we're going to do all the testing. So I'm going to go back in and align this thing. It's going to be about 50 or so on FM. Deviation will be about 3.95 kilohertz on FM. AM carrier is going to be about 20. I still say the preferred area to run it, if you want to run it all the way up, is about 16. That's the better spot. 20 is, it's still okay, but lower it down a little bit is better. and then 1 watt on the low end of AM carrier, 1 watt on the low end of FM carrier. Sideband, it's going to be proportional to where you run your RF power, as well as AM, although AM on these radios is a little more aggressive, so even with the lower dead carrier, you're still going to get a lot of forward peak on this radio. But on sideband, it does limit it based on where you put it. So you want to do less power, just turn that RF power down. And on AM, it kind of does the same thing, but the modulation level on these is very strong, which kind of drives the, the MOSFETs to a higher power level. A lot of guys like that, so I can go either way with radios. I kind of prefer it this way, just because it's more fun. If you have a meter that has real true peak reading capability, you'll see quite a bit more power with a radio this way, although you still do on the other ones too. But if you don't have a good peak reading meter and you just have like one of those other ones, like I kind of named the beginning letters, a lot of those other branded meters, you're not going to see squat on this or any other radio anyway. So I would highly recommend that anyone that's seriously going to spend the money on like something like this or anything comparable, or if you're spending over a couple $300 on a radio and you don't have a good quality meter that reads real peak and stuff, then you're kind of, as a hobbyist or a radio user, you're doing yourself kind of a disservice. And I'm not saying that to be a dick or anything. I'm just saying that as I would love everybody to have a quality meter, and that way we're all on the same page. If everybody had one of these, I'm sure Telepost would love it too, but I would love it because then we're all on the same page, and then it takes out so much of the guesswork over everything else that guys get confused about and stuff like that. So, but I understand that not everybody wants to spend money, but if you do it once, I mean, longevity wise, I think this thing will last a long time. So anyways, let's get the alignment knocked out and I'll come back and show that when it's done. Just one more thing I wanted to point out. There's some international guys that reached out to me about these. I do have more. I just haven't had a chance to get to you guys as quotes and stuff. So if you're watching this video, I do apologize, but it will happen. Just you got to have a little patience with me. And some guys aren't willing to wait, and that's understandable too. But I have a full-time gig, full-time job, a family life. My job gets busier this time of year, so I'm spending more time at work and less time with the family, and then obviously less time with this. So everything is a give and take. Okay, there's the transmit frequency, so it's looking good. This is for AM and FM. Here's your low AM modulation. See that huge spike up and then it falls back. That's just the tone ramping up through there, and then the limiter kicks it out. So it's about 120%. It's impossible to get like super high modulation numbers. I mean, you need to have something like what I showed you in that other video, because it's just not possible with a traditional radio to really get like super high numbers. I mean, the only way to do it is to sacrifice the negative peak, the other side of it, and usually the top end flat tops as well. So you just can't do it. You can get quite a bit of modulation, but you're never going to get a super high amount, like 200%. And most guys probably don't want that anyways, but when you do it the right way, it actually works pretty damn good. So let's see what we got here. And so far I'm really happy with my decision on my Kenwood there, so no complaints. No complaints at all. I'm just trying to get something squared away here over on the spectrum analyzer. So okay, that's close enough. So I do run the noise gate on these radios. I would recommend leaving it on all the time. It's preset with it on. That's the carrier right there. It's about, what, I'm showing the dBm ratio, but it's about 20 watts there. So we're going to run the tone. I haven't adjusted this one, so I don't know how it's going to end up. It's really not too bad already. It's a little over 100%. I think you can take it up just a little bit more. And you get to a point though, you see how you start to flat top and then you negative compress. You don't want that. That's just garbage then. So again, like I said, you can't really do much more than just a little bit of an improvement. It's not going to be a huge big change, but, and again, this is at the 20. When we lower it down to 16, you actually get a little more audio out of it, and obviously on the lower power side as well. So it's one of those things where these are loud radios already, but you can only do so much at the radio side. Sometimes you need to have something else done where you bypass the whole radio AM circuitry and get something else, you know, put in. And I wouldn't necessarily recommend that for someone that doesn't have the ability to understand the test equipment side of the hobby and stuff like that, because it's a little more I mean, he probably does a good job explaining it to you and everything if you wanted him to, but I'm not gonna take anything away from what he's doing because it's awesome and I'm no expert at it, but I just definitely made it work good for me on my Kenwood, so I'm happy, really happy, and I'll just leave it at that. So that's that. That's how it looks on the spectrum analyzer. So it looks good, it's clean, with the 1K tone. Power wise, on average, it's about 30, almost 40 from 20. PEP, it's about 70 something. What's it going to do up here on PEP? On this, it's almost 80. So pretty darn close anyways on PEP with the 1K tone. It's good. Okay, now we're doing sideband. This is the bad side of the radio here. When they come out of the box, they're terrible. So unfortunately it's the way it is, but you know, we're pegging the 100 almost, and we're pretty much at 100 here, but it looks terrible here, and then we're taking up a ton of amperage, which we don't need. And you watch when I linearize this waveform. I know that's a big word, but you know, I just make it look rounded, basically is all I'm saying. As I make this look more rounded, the amp draw will drop considerably lower. Oops, this thing is acting up. So it's just a combination of the PA circuit, the power amplifier in here, for better or worse, is not linear, which is not good. And then you take this and put this into a linear amplifier, which in a lot of cases aren't linear either, depending on what it is, and then it just becomes a total disaster. So we don't want that. We want to try to at least make the radio as linear as it can, so that way you can have a little bit more respectable signal coming out of this thing. So as I level out 1 and 2 up here, which is one of the tones is this one of the tones is this one. I always move 1 because 1 is easier to adjust. Actually, I move 2, sorry. We want to get those as close as we possibly can, and that's about where they're close. I mean, I can play with it, but pretty damn close there. You can see the power didn't change, nothing changed. This actually looks worse now, and our current draw is just about the same. So what we're going to do now is just run the test, and it's right here, and they're always 12, so it's no big surprise there. I want to make that at least 20. That's a big improvement. So I don't know if I can I don't know if we can kind of see everything. Yeah, I think we can kind of see everything like this. So watch as it gets rounded. And I don't know how many adjustments I have to make, but we'll just kind of look through the camera as I do it. The amps are dropping back, the power's dropping back. That's 17 right there. There's 19. That's actually 22, so we're going to go a little bit ahead. Okay, so that's good there. Look at how less of amperage, you know, quite a bit less now. It's very linear. And we dropped about almost 50 watts, 40, 50 watts down, which is fine, because when we talk with our microphone, the PA is still going to do the power. I want to make this as linear as you can with a two-tone test, and that's the only way you can adjust sidebands with a real two-tone test. You can't do yelling audio into your mic or any of that nonsense. So you have to do it like this, and this is the best way. So, and you can see now if I enlarge this some just to take a look at it, how much nicer that looks now. So everything is working linear, and that's it. That's all you have to do. As you lower the power on this, everything else will be linear too. So, you know, the radio, it's kind of hot, but this thing's got a hunkin' heatsink on the back, so you don't need a fan on this radio. If you wanted one, you just do it because you wanted one. You definitely don't need one. It's going to stay cool just by that heatsink. I mean, it's pretty hot, but I've been running it pretty hard here, but you have to really see where you're at with it. So let's get out of this and go here. And now I'm going to put this Road Devil mic on here just because it's handy. And we'll take a quick power check. And then I'm going to get yours all wrapped up. Okay, so I got the Road Devil on here. We're going to put this on peak. The little power cables are hot. I can't remember if I think I have a 15 amp fuse on each one of these. So we're pushing it. You know, a lot of current going through there. That fuse was saying, come on. It's probably happier now. So, alright, so let's check the sideband. So, first thing we're going to notice on sideband here is we're not going to see a ton of power on the display. That's okay, that's normal. So I wouldn't worry about that. They're all like that. On upper sideband, that's how we're looking right now. It's looking really good. And it's about, I don't know, 3 to 3.5, maybe 4 kilohertz at its very maximum, which is fine. We don't need to take up too much bandwidth on sideband. So now we're going to look at power. And power on this radio is usually about anywhere from, I don't know, 70 to 100, which you can see as I speak. And I kind of pause between my words and stuff, how it reacts on the meter. You can also see on the analog meter what it's looking like on PVP. It's about the same. This has a slower decay time on the meter, but everything works the way it should. So we're looking mighty fine here, just how we expect to, you know, look. We didn't lose any power on the operating side. What we did is gain linearity, which is a big improvement on all these kind of radios. They need to have that. And that's something that, you know, if you can't do it, you're just pretty much, you know, you would never know without somebody showing you, because most guys wouldn't have the spread to really test for that. But I just lowered the power down, so let's see. When you lower the power down, now you can see less power here, of course. So like I said, the dial is pretty linear in the sense on sideband that you can see less. So if I take it all the way down, this is all the way down here. So all the way down on this radio is less than 20 watts. 1, 2, 3, 1, 2, 3. And you can see that here, even though that scale wouldn't be very accurate, but it's less than 20 watts. So now we're starting AM at that low power level. So we're sitting about a watt. So we're sitting at about a watt, and then as we talk, this radio has a lot of modulation, so you're going to see sometimes big power jumps from that 1 watt. It's not real consistent, but at times it does kind of let loose. Now this is where these meters become less reliable. They don't have the peak detection, the ability to lock onto signals. They just kind of hover around and get stuck up in a certain range. So this one makes the radio look even like, oh man, look at that, 1 watt swinging 80 to 100. But as you look at this meter, is a much more reliable meter, and the peak circuit's designed so much better. It's so much faster. It reacts to ongoing, you know, as the signals pass through the directional coupler, everything is basically registered within the instantaneous, where this meter is slow and not very responsive. And it keeps getting hung up on high power. This is a 100 watt element, by the way, but this is entirely not true what we're doing here. So, but if somebody shows you this, oh man, that looks really good. Look at all that power I'm doing. You know, that's why these are invaluable for what we're doing here. So this is how it looks here. Now, I know I'm not really in scale, but that's how it looks. So it looks good. We turn this all the way up. So there's how it looks all the way up with voice. So again, it's a little more aggressive than some of the other models that are on the market, but again, it's not really going above the 0 dBm into the next channel, which is good. So, but it is at this point, you know, we're going to do closer to that 100 peak envelope power, and up here it's basically putting it in the corner. But that's what it does. So if we want to look at let's look at what I was talking about with the 16 watts. There's about the 16 watts. Let's look at the average. Now these meters are really good on average power too, so you know they have a good response on average power, and there's some settings in there that a friend of mine has one of these too, and we talked about it, and he made some changes because he wasn't at work and I was, but we were talking about it while I was at work, and he found that by moving a couple settings, the average power is way more responsive, and I found the same thing. So it was kind of cool that you could unlock some things on this meter with just a few setting changes in there. Because watch this one. So on this one, you don't really see too much average power, and that's why I say even these bird style meters and stuff, if you're seeing a lot of forward movement on like a bird or a coaxial dynamic, one of these meters, I would be concerned, because I still don't think these are capable of showing you like true RMS with voice. Like this meter is designed to be able to react to that and show the proper, you know, power number, where these just don't do that. So if you're seeing a big swing on a bird or something like this in the RMS, I would say that the radio's heavily transmitting a lot of RF distortion. And that may not mean that you sound bad, but it definitely is bad for the RF spectrum. And if you were to monitor that radio on said spectrum analyzer, it would look terrible. I can assure you of that. But this radio doesn't do that. So that's why these are what they are. They're good and not so good. And I could say the same about the bird. Probably the bird that's way more money, which most guys don't have, that has, you know, the CW and peak switch on the front. It's just a way more expensive meter. Probably is much better. And I believe that there's still that one, and I just can't remember the model number, that is a true RMS reading meter. Has a battery only for RMS, and that one would be much better. Actually, my MFJ giant watt meter does a hell of a job for RMS readings, much better than this or my bird. So I like these, but you know, when you have something and you've used it long enough, you can kind of critique it a little bit, and I don't feel bad by doing that. You know, it's just part of getting used to using your equipment. It's a fun meter though, and I like the dual line section. It's one line section with two inputs, and you just flick between here and here. This is always on anyways because it's going straight through. Actually, it's going this way, but you know, the signal passes, this picks it up and samples it out to spectrum analyzer. So that's what it's doing. When I have it flicked here, it's on this. So either way, it works. So, all right, Paul, let me connect this to my antenna really quick if I can, and then we'll get yours wrapped up. This is a long one. They're not always like this. I don't know. I haven't done radio in a little bit, and I wanted to show a couple things, and I get carried away. So it is what it is. Let me reframe what I said so that I don't confuse everybody. We were dead keen about what, 16, and sometimes we were going to like 30 on the RMS. That's okay. I would be happy with that. If this was showing that, I wouldn't question it. But if we're dead keying somewhere, let's say 16, 18, 20, and somebody keys up and yells audio and all that stuff, and this thing's swinging to 60 RMS or whatever, then I would question that. I wouldn't want to buy that radio for my own use. Let's just say that. So knowing what I know and being able to test things, I would stay away from that radio. But that's just me as an operator. Now, if someone else might like that, you know, that's entirely up to the user preference. I also use DX cable. It's good cable too. I like ABR, but I like DX engineering stuff too. I like RG213. I don't run a lot of stuff here where I need to worry about power limitation of 213. I like it. Okay, so we're on the receive side. So the skip's coming in pretty good today. I haven't been on the radio other than when I turned it on. I'm just in here. I haven't talked to all yet. This is your receive clarifier, so you can make that receive and transmit together if you want. That's up to you. It's in the menu. So now I'm on this antenna is connected to a big low pass filter outside at the tower, and that's why I'm not picking up anything here, which it's doing its job. So hats off to the low pass filter. Anything above 30 megahertz is attenuated down 80 dB, so I'm not going to hear it. That's why it's not hearing it. But if you don't have a low pass filter in line, you would hear it, as we did on the dummy load. So just wanted to show that. I believe in running clean radios and running filters on my output. It doesn't hurt you. If anything, it just helps. So I even run a bandpass filter for 27 megahertz off the transceiver, off the back of it. I don't care. Every bit of filtering, I'll take it. Anything I can do to filter out any unwanted crap, if there's anything there, I'm all about it. But that's just something I like to do. Doesn't cut out anything on receive or anything. If anything, it probably helps the receiver block out unwanted interference at times. Okay, Paul, obviously you can change the color if you want to. Remember, there's a plastic film that will peel off, and the whole thing comes off, the front. It'll just start to peel off. It'll peel up around all the controls and stuff. So if there's any little bubble looking things later, if you don't take it off, that's what that is. And eventually, if you run this in any heat outside or in a mobile or something, you're going to want to probably take that off. If it's in the house, you can probably leave it on for an extended period of time. That's up to you. I appreciate it. Hopefully I answered all your questions, and anybody else that was wondering about stuff on these. 73.